Okay, so let's talk about the chi-squared contingency table. So, unlike the goodness of fit chi-square test, which uses the extrinsic model, that is, it has theory external to the study which guides us in the calculation of expected values, we don't have that here. So the contingency table uses the intrinsic model. So what this means is that basically we have to calculate our expected value. What we have here is a table showing progression of AIDS for patients co-infected with HG, hepatitis, which is now called GB virus C. So it shows that the proportions of people, the HG plus is people co-infected that lived past the study end date or died during the study. So saying we were conducting a study, our experimental question then could be, do HIV patients co-infected with HG progress to AIDS at rates different to those not infected? And we're not even asking if it's faster or slower, we're just asking if it's different than those who were not infected. So our null hypothesis would state that there is simply no association between probability of living past the study end date and co-infection with HG. So for a contingency table, what this means is that there should be the same proportion of individuals with and without HG that either lived or died. By the way, let's call each of these. So this one would be cell A, this would be cell B, cell C, and D. How do we actually compute the expected values in the 4 cells? So first of all, we need to work out the expected proportion of patients that lived in the entire sample. So that'd be 198 over 362 is 0.547. Secondly, expected proportion of patients that died in the entire sample, or a brief summary of what we've done so far. We've arranged our observations in a 2x2 table. We've calculated our expected proportions, expected values under the null hypothesis. Now we proceed to conduct the chi-square test. So for cell A here, the observed minus expected squared divided by expected would be 7.45. And this gives us a total chi-squared value of 27.34. So now if we consult a table of critical values for alpha equals 0.05, and as we have 1 degree of freedom, the critical value it would be 3.8 for 1.